now let's take a look at 6.4, surface of revolution. So it's basically, instead of being a solid that you're revolving, you're like an area and then revolving the area, you're going to take the surface or a line and revolve the line. So we're going to derive a formula, but this is what we call in math the hand waving version, because when you're normally teaching, you're like, look, it just does this, and you can't see me with my hands, but that's what you do. It's we're not going to go through the whole derivation like I did in 6.3 with arc length, but you'll see how the formula is, why it would make sense after I show you this, hopefully. So suppose you have this graph. This is your function f. Okay, I'll just put f there. This is f. And we're going to take this and revolve it around, say, that axis. But we're not looking at the volume of it. We are just looking at the surface area. So the figure looks the same, but just the outside. Excuse me. So suppose you take that and revolve it. So it would look kind of like this. Let me duplicate that so it gets about roughly the same height. Duplicate that and here. And then it's going to look kind of like this, more or less. And what we're looking for is basically this little strip here. So take a piece of the line like that, and then actually helps to make it smaller when I do this. And then we're revolving that like this. So it's going to be this little strip. It goes all the way around into the backside too. Okay, so it goes in the backside. So it's this little strip. So it's not anything in between. So what it's like is doing this. It's like taking a little piece. Oh, I almost forgot. Circumference of a circle is 2 pi r. So we know that, right? It's 2 pi r circumference. So the radius times 2 pi gives you the circumference of a circle. So all the way around the circle is 2 pi r. So when you do this revolution thing, picture, let's do like a circle like that. And so all the way around is 2 pi r. So 2 pi times the radius, or whatever the radius is. And keep in mind, what's the radius going to be? The radius is going to be the function value. That's just like we did before. The function value is the radius, okay? Now, let's suppose you want to find the surface of that. So it's basically this piece here, which is like a cylinder, right? It's like a cylinder, but it's not the volume of the cylinder, it's the surface area. So if you derive a formula for the surface area of a cylinder, it would be this, and I'll just do this real rough and brief. The surface area of a cylinder with a radius r, and you can look this up to verify everything here, is you take the circumference of the circle like that, which is the circle, which is 2 pi r, okay, and then you multiply by the height, or the altitude or height. So it's times h, whatever that is. And then you add the area of the two bases. So what's the area of a circle? It's pi r squared, but you have two of them. So it's 2 times pi r squared, which is the area of the circle. But we're not interested in, excuse me, we're not interested in that area of the circle at all. We're interested in just the outside piece. So we're not looking at this at all. And so what is that thickness? Well, we actually calculated that little piece there, or that's like your h, right? You see how they're the same? And then if I do this right, I can actually bring this over and twist it Okay, so that's the height, right? It's the same looking thing like that. Okay, so that's what we're looking at. That's that strip right there of how you add that up. We're adding up all those pieces, but it's just the strip as you add it up. Okay, so that strip, that height is what we derived earlier. That's the thickness. That's the the arc length. So the arc length here is that square root of 1 plus f prime squared dx. So we derived this whole thing here to figure out that little piece. So that was the end result once we did the derivative and everything. So picture it like that. It's actually more of the sum and stuff. But so what we end up getting, r is the height, right? So that's your r. R is the function value. So our surface area, capital S, ends up being the integral from, and then whatever your limits are, so a to b of 2 pi times the height times the altitude or the thickness, which is the square root, like we derived before, of 1 plus f prime of x, quantity squared, and then the dx came out in the derivation. So what I highlighted there, this piece came out in all the derivation we did, but that's how you can interpret it or kind of think of it. So that's the formula for surface of revolution. And you can just apply it directly. We're not going to spend a lot of time kind of figuring all the details out. But that's gives you a little more motivation where it comes from. So I'm not going to go, you can look at the entire derivation if you'd like in the book. But I did it before for the for the arc length. Okay, so now let's look at an example. Kind of a simple one, but it's fine. So find the surface area if the graph of y equal to square root x from 1, 1 to 4, 2 is revolved about the x-axis. The only thing that might change a little bit on this one is if we revolve it about a different axis, and then you do like the difference to find the radius. So if you took this and revolved it about a different line, like that, then you just take whatever value that is, y equal to b. So b minus f gives you that full distance. That's all. We won't be doing that though. Don't worry about it. Just know the basic formula here. All right, so let's take a look at the form. So let's graph. I always want to graph first. So we're looking at that as root x. So y is equal to root x. And we're going from, what was it, 1 to 4. So let's just call this 1. I'm not going to match anything, just kind of free flowing today. So 1 to 4, so it's this piece right here is all we're looking at. That little piece is being revolved about the x-axis, and it's going to create that little strip. It's going to create a strip like that and like that, and so it's this strip. That looks horrible. Just leave it alone. It's right there. You can picture that. Excuse me. Okay, so the surface area S is equal to the integral, and then you just use the x values, 1 to 4, of 2 pi times the radius, which is right, that's the height. That's the height of that, which is the root x, times the square root of 1 plus, and then now you got to take the derivative of root x. So the derivative is 1/2 x to the negative 1/2, and then it's quantity squared dx. So let's simplify that. That's equal to, let's factor out the 2 pi to simplify a little bit, 1 to 4, and then that's just x to the 1/2. Square root of 1 plus, and then when you square that, you get just 1 over x. So that's just 1 over 4x dx. And then let's simplify that a bit. So you get equal to 2 pi integral 1 to 4 x to the 1/2 square root of, and then let's add it up, 4x plus 1 over 4x dx. One to 4. Simplify that some further. Take the square root of the 4x, and you get just 2, and then so you get x to the 1/2 over 2x to the 1/2 square root of 4x plus 1 dx. And I mean, pretty much from there, you can get it. So it's pi 1 to 4, and then the rest of it you're going to do. So that's pretty straightforward. You pick u to be 4x plus 1, and then you just get 1/4, etc., and you simplify it. I might do that later just to show you if I get an actual number on the next video. But normally these are the sort of things we do in class, and so I have you figure it out, and we compare answers, etc., and we're good to go. All right, so surface area, more or less, I mean, it doesn't need to be in a whole section in the book, from my opinion. But if you want to look at how it's derived, it's all there. And of course, because of our format, or even normally in class, I wouldn't have you memorize any of this stuff. You can just, give it to you type of thing, or you can use a note card. So that's all we need to do for that. Know the basic, formula. Try to understand. Spend some time. What I mean is understand how it's derived, why it would kind of make sense. With this is like the height of that thing, and then times 2 pi r. That's what I need you to visualize, that concept. Okay. Next, we'll go on to 6.5, which is work, which is a big section. And then one more section. That's it for chapter 6.